Still working with the radian word problems. We have electrical wires being wound around a drum with a radius of 0.79 meters. Okay, if 2.18 meters of wire is wound around the drum, now think about it. You've got a circular item here, and they're telling you that the radius is 0.79. Okay, if this is how much wire you have, remember it's going on the exterior portion. So that means this is the part that you have that is 2.18. It wants to know what angle to the nearest degree is it rotated through. So remember our lovely little formula is SOAR, and this angle right here must be in radians. So when we work our problem out, we're going to get radians, and we're going to need to convert it back to degrees to have our true answer. So we actually have the arc length. The arc length is the length of the wire. Okay, we do not know the angle. The radius happens to be 0.79. So we're going to divide both sides by 0.79. So I've got 2.18 divided by 0.79 is 2.759. Let's do that. 95, round it up. Okay, that's radians, guys. So you don't want radians because that's not what the problem asks you for. So you've got to convert this thing to degrees. So you're going to come over here and you're going to do 180 divided by pi. Remember, you put the one that you want up top. We want degrees, so 180 goes up there. So don't clear your calculator. Keep all of your lovely little decimals in there. Go ahead and multiply times 180 and then divide by pi. And you will be able to round your answer, and it will be precise. You don't have a bunch of rounding errors in it, put it that way. We want to the nearest degree. So nearest degree, I got 158.1, so 158 it is. Okay. So here we go. Same idea, we're still working with the SOAR formula. Find the radius of a pulley. If rotating the pulley 119.10 degrees raises the pulley 29 millimeters. Now think about that. If it raises it that much, that means you have, if you got a wire coming down here and this thing is spinning, it and the wire still going around the edge. So this is really arc length, okay? It's S. And so we got SOAR, and we've got 29.0. We know our angle. It just happens to be in degrees, which means we have to convert, but that's no big deal. Just put your little conversion factor in there, and it wants to know what is your radius. So find the radius. So here goes. Let's first of all, I'll tell you what, couldn't you just divide both sides by this massive thing? If you do that, let's take this out. It's probably going to be easier to type. We're going to type 29 divided by, and then in parentheses, put 119.10 times pi divided by 180. And it should work out lovely. What are we supposed to round to? It did not say. So I'm going to go with, what are we looking for? Radius. This is the other length measurement we have. So let's mimic that for what we need. That's going to be 14.0. Because I had 13.95 on my screen. So if I'm going to put it in terms of what I was given, 14.0 is going to be it. Okay, area of sector. So area of sector is, let's see here, 1/2 theta r squared. I do believe that's right. Again, the same rule applies. You're wanting to put this in radians to make it work. So whenever you go through and work it, be mindful of that. So this formula right here, you're wanting the area. We've got the 1/2 theta. As usual, they're going to give us degrees, so you're going to have to work for it. So you've got 23.860 times pi over 180. And then our little radius is 20.11. That's going to be squared. It's just a matter of typing, guys. So you got 0.5 times 23.860 pi. Oops, my calculator has messed up. I've got to start over. Sorry, guys. So 0.5 times 23.860 pi divided by 180 times 20.11 squared. Okay, that gave me 84.206. But what did they want you to? They didn't tell, so let's do significant digits. This is a let's see here. We're going to go with the, let's do 84.21. That'll do it. Feet squared. Okay. Now find the exact circular function. Okay. So circular function is just in radians. We need to sketch it and label sides. 5 pi over 4. That is more than 1 because 4 pi over 4 would be 1. So that we're in third quadrant. Reference angle is pi over 4, which happens to be 45. So your brain needs to think about a 45 degree triangle. We got 1, 1, square root of 2, but we went left and we went down. So sine of that picture is going to be -1 over square root of 2. We need to fix that by rationalizing, and that's what we get. All right, so tangent of 7 pi over 6. Once again, it's over 1. And it's over 1 by pi over 6, which is the same thing as 30 degrees. Opposite the 30 is a 1. We have square root of 3 on this side. We have a 2 here, but we went left and we went down. Tangent is opposite over adjacent. Now, there's several things wrong with that. The negatives have got to cancel, and you have to rationalize. Okay. Now, then we need secant of -5 pi over 3. Okay, now notice, negative means we're rotating the opposite direction, and we're almost getting full circle, because full circle would be 6 pi over 3, which is 2 pi. So we're coming back around here, we're in first quadrant, and our reference angle is pi over 3, and hopefully you're thinking, oh, that's 60 degrees. Opposite the 60, square root of 3, adjacent's 1, hypotenuse is 2, everybody's positive because we're in the first quadrant. Now we've got to think. Reciprocal of secant is cosine. So we're going to do cosine and we're going to turn him upside down. Cosine is 1 over 2, so flipping to him is 2 over 1. We just get 2. So it's not as bad as the same stuff, just in a different format. So use your calculator to evaluate the function. Now keep in mind, we're talking radians here. There's nothing marked degrees. Remember, all degrees, they've got to have the little degree symbol up there. If you've got this value here, that is radians. You need to change your calculator. So grab your calculator, go to mode, and get it in radians. Okay? Otherwise, your answer is going to be tripped out. Okay, so we're going to type tangent and then 0.2229, enter. And what's weird is it doesn't change a whole lot. That's what we get. So it just looks a little odd when you're doing radians, but you got to remember how they're measured. 1 radian is around 60 degrees. So find the value of S, which is just your angle. If that bothers you, change it to X. In the interval of 0 to pi over 2, so we're doing first quadrant, remember, that makes the statement true. Again, it's radians, guys. So approach it the same way we did with the other. You don't have a secant button. Whether you're in radians or degrees, you don't have a secant button. So again, we got to do reciprocals. So we're going to do the reciprocal of secant is cosine. And there's my S. I'm going to offset him so he doesn't look like he's part of cosine. And then I'm going to do the reciprocal of this side, which is exceedingly long. Okay. Now, I need to get rid of the cosine. Remember, that is the inverse cosine, which means you guys are going to use your little second button. Second, cosine, and then I'm typing 1 divided by 4.1924279. And that gives me S to be 1.330 if I'm rounding to 4 places. It didn't really say where to round it to, so that's what I'm going with. Okay, match the function with its graph. Okay, and then y'all know that tangents and cotangents work this way. You can remember the shortcuts we talked about. Tangent, just a normal traditional tangent, which is your basic parent graph. He has a positive slope. Cotangent has a negative slope, so that makes this easy. Okay, so tangent is going to be B and cotangent is going to be A. All right. Keep in mind, you could think unit circle if you needed to. This is 1, 0, and tangent is always going to be sine over cosine. This is sine and this is cosine. So if I do tangent of 0, 0 is 0 over 1, which is just 0. So the one that goes through 0, this one, is tangent. Cotangent is cosine over sine, which would be undefined, 1 over 0. So that would give you A. So there's a couple of different things that you can do to figure it out. We're headed for the other reciprocals. We have secant of x and cosecant of x. Remember, they're built off of the reciprocal function. So this is built off of cosine, and this is built off of sine. And remember, they do their little parabolas off the peaks and valleys of the graphs. So think about it. You see this one right here where he hits there? Can't you imagine the original function in here? Going through and doing that? Which one did that? Was that sine or was that cosine? And if you can go in and you can sketch these items, that lets you know, oh, sine starts at 0 and cosine starts at the amplitude. So it lets you see where their reciprocal functions are. Just a sneaky way of figuring them out. So use the fundamental identities to find the value of the trigonometric function. Okay, so we have cosecant. We want to find cosecant if we know cotangent is equal to a negative 2/3 and is in quadrant 4. Okay, so let's go to quadrant 4. We're going to drop a triangle down in there. And we know cotangent is, instead of opposite over adjacent, it's adjacent over opposite. So the adjacent side is going to be 2. The opposite side is 3. Remember, when it's negative, nobody promises you that the negative goes with the top. You don't know who he came from. It could go with the top. It could go with the bottom. You got to draw your picture to figure it out. 3 is the one that's hanging down, so 3 is the one that gets the negative. Now, we need to figure out what the hypotenuse is because that is not a special situation. 2 squared plus 3 squared. Remember, it doesn't really matter if you put the negative in there because it's going to go away in the wash anyway. So we got 4 plus 9 equals x squared. We got a square root of 13. Okay? So if that's the case, cosecant, remember he's the reciprocal of sine. If I do sine and I turn him upside down, I should get cosecant. So sine here is opposite over hypotenuse. We'll go backwards. Hypotenuse over opposite. There's nothing I really need to fix. That will work. It just bothers me to have a negative in the bottom of a fraction. Remember, they're normally out front or in the top. Okay, find cosine if you know tangent is 3 and sine is less than 0. This is giving you a hint. This is sine is negative, tangent is positive. First of all, you've got to figure out which quadrant that is. For sine to be negative, this is out and this is out. For tangent to be positive, it's got to be here. Now, if we take this 3 and we make it a fraction, then we can label some sides. Tangent is going to be opposite is 3. Adjacent is 1. This is left and this is down. You've still got to find your hypotenuse. 3 squared plus 1 squared equals I don't know squared. So 9 plus 1 equals x squared. So we got square root of 10. All right, if you want cosine of that, cosine, okay, I got to line this one up. Cosine is going to be adjacent over hypotenuse. You do need to fix that. So we need the negative, but we need square root of 10 over 10. There we go. All right, we'll pick it up with the next video.